Hello viewers, now I discuss very important examples, better to say, it is a part of examples in measure and which is very much important problem. A bounded set E of real is measurable if and only if, that is IFF statement, if and only if its characteristic function, that is called chi or x, whatever may be the notation is, chi, generally say chi E is a measurable function. Then we have to prove this result. This is a measurable function. At first, to prove this result, here we needed a bounded set of real is given. So let us consider E is a subset of AB in the closed subset of closed interval AB, and then we can say that possibilities of chi E or characteristic function of E of x. So there are the two possibilities. Either x is belonging to E, another kind is x is doesn't belongs to E. That means x belongs to elsewhere, any position of AB, closed interval of AB, rather than E. So certainly if it is total set, that is 1, possibility is 1, its characteristic, that's why we find here the indicator function. So we use here 1 and 0 conditions, and then we can easily find that chi E of x is 1 if x is belonging to the bounded set E, and another possibility is we can say it is 0 if x is belonging to elsewhere. That means closed interval of B minus of E or slash of E. It is a notation. And then, and suppose that the characteristics function chi is such that AB to R is measurable, and then E, we can say E, that x, what is E? E can be constructed in this manner. E is a set such that x is belonging to closed interval of E such that chi of x, chi E of x, that is characteristics of E of x, that is positive, that is greater than 0, so which is measurable. So we can easily say there is a measurable if it lies on E, and as per the constructions we can say this is a map from AB to R. So in this approach we can say that these elements, that's a measurable function. It is clear, obvious result. And now we are taking the converse, because we are making here the IFF statement, that is if and only if. So conversely, if E is measurable, we can assume that E is measurable. Then we have for any real alpha we take, and we construct a set that x is belonging to closed interval of such that chi of x, E of x, that is greater than alpha. The condition possibilities, we are taking the three branches here. At first, if this real number alpha is greater than or equals to 0, then we don't find any existence, so it will be null set, null and void set, and we can find any kind of this result. And if here this alpha lies between 0 to 1, that is a characteristics function, proper characteristics function, so it will be the entire set. That's why we take E. And if alpha is less than 0, that means more smaller, and that's less than 0, this condition only satisfies this interval. That's an interval condition, not the whole set. So we can say it is closed interval of AB, and where each measurable on RHS is measurable, so phi E all are measurable, and so we can say that chi E is a measurable function. So in this way we study the characteristics function is measurable, whatever may be the branches of is, we construct and we demonstrate this type of problem, how to solve these problems. We end our discussion today. If you like this video, like it, share it, and always subscribe the channel. Thanks for watching.